In section 6-8, you're going to learn how to graph a radical function. The essential understanding today is that a square root function is the inverse of a quadratic function. But it has some things might have a restricted domain. So what I'd like to talk about first is the original function. Let's say that you have f of x, and f of x is the shape of a parabola. As you can see, the parabolic shape goes up and down. Now what you need to see here is that the parabola passes the VLT, the vertical line test. Therefore, it is a function. Look at the inverse though. The inverse we call f of -1, and it does not. This would be like a plus and a minus square root one. This one does not pass the vertical line test. Okay? Now, if you restrict the domain, okay? So take a look at how these two graphs are related. They're saying if you restrict the domain just to this side, then the inverse will pass the VLT. So you can see that we have restricted the domain, and we've restricted the domain to be greater than or equal to 0. If we restrict the domain to be greater than or equal to 0, it will then, the inverse will pass the vertical line test. And therefore it will be a function. So remember, if we restrict the domain over here, that means over here we have restricted the range to be greater than or equal to 0. Remember, the domain and the range flip-flop from a function to its inverse. Look at the key concepts below. Just like you were used to whenever we are graphing parabolas or when we are graphing absolute values, if you put a negative out front, that's going to flip it upside down. If you put a number out front, that's going to either vertically stretch or compress it. And then if you put things inside and outside, this one's going to move it left or right. This one's going to move it up or down. So none of this should be new to you. These always either flip it upside down, stretch it, compress it, move it left or move it right, move it up or move it down. Now, something that you need to remember is this thing called the parent function. Let's say that we have y equals the square root of x. What's the xy chart for that? Alright, so this would be, we're talking about the square root. Should you make that real big? We want to talk about the square root parent function. Now we have y equals the square root of x. What would be some good numbers to plug in for x? Well, things that we could take the square root of, right? Can we take the square root of a negative? No. So we're going to say no negatives, because we can't take the square root of a negative. I'm going to pick really nice numbers, okay? So pick nice numbers. If you pick nice numbers, you want to pick squares. So if I do 0, what's the next square? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9. Now why would I pick those? Because I can do the square root of each one of those. I can do the square root of 0 is 0. I can do the square root of 1 is 1. I can do the square root of 4 is 2. And I can do the square root of 9 is 3. So that is what I would always use for your parent function xy chart. Now, how can you find the starting point, of an exponential function? You always want to look, ready? Look inside, you ready? Look inside the square root. Make the inside equals 0. That's the starting point. Okay, you ready? So let's have an example. Let's say that we have y equals the square root of x plus 4. Well, on your xy chart, guys, you would start at -4, okay? Because you want to think about the opposite of what's inside. And then you would count up, just like we counted up over here, okay? See how we count up by 1, we count up by 3, we count up by 5. You would do the same thing down here. You would count up by 1, you would count up by 3, you would count up by 5. Okay? Pretend on the other hand that you had the square root of x minus 2. We'll do the opposite of what's in there. So you would start at 2. And you would go up by 1. Then you'd go up by 3. Okay? You keep that the same. And then after that you go up by 5. Why would you go up by those amounts? Because that's going to keep your square root perfect. Okay? So let's write a little note up here. To keep the square root perfect, comma, always skip by up 1, up 3, and up 5. Alright, let's take a look at this one. Notice on the first equation, we have the square root of x, and outside of that we have minus 2. So what that's going to do is we are going to, on this one, we're going to keep x equals 0 for the first point. Alright? Now take a look at this one. Can you see how the plus 1's on the outside? That means we're going to keep x, the first one, equal to 0. Now, you should understand that this thing is just going to move down 2 units, and that this one's just going to move up 1 unit. Okay? So let's make 2 xy charts. This one will be, we can write it up here so you know which one we're doing. That one will be for the x square root of x minus 2. Let's plug in 0, 1, 4, 9. Let's plug these in. So we do the square root of 0 minus 2 is negative 2. Then we do the square root of 1 minus 2 is negative 1. Then we do the square root of 4 minus 2. Well, the square root of 4 is 2, minus 2 is 0. Then we do the square root of 9 minus 2. Well, the square root of 9 is 3, minus 2 is 1. Let's plot these points. 0, negative 2. 1, negative 1. 4, 0. 9, 1. I didn't add quite enough things, so just go ahead and kind of skip over so you get it, okay? Now let's draw our line to connect. And look how that one is almost like, you see it? It looks like half of a parabola. Well, it should look like half a parabola. Let's do the other one now. We have the xy chart. Okay, that's for this one. We're going to do the square root of x plus 1. Okay, we're going to keep x starting point at 0. So we'll do 0, 1, 4, 9. Alright, the square root of 0 plus 1 is 1. The square root of 1 plus 1 is 2. The square root of 4 plus 1, well, square root of 4 is 2, plus 1 is 3. Okay? The square root of 9 is 3, plus 1 is 4. Let's plot our new points. 0, 1. 1, 2. 4, 3. 9, 4. Can you see how they're both exactly the same shape? One is moved up 1 point from the origin. The other one's moved down 2 points from the origin. Let's try the got it. Okay, so let's do this one over here. Let's do the square root of x plus 2 on the left. Let's compare that then to the square root. Y equals the square root of x minus 3. Notice x is kind of by itself. So we're going to start at 0, 1, 4, 9. And over here, the same thing. X is by itself. So we're going to start at 0, 1, 4, and 9. Let's plug things in. The square root of 0 plus 2 is 2. The square root of 1 plus 2 is 3. The square root of 4, which is 2, plus 2 is 4. And the square root of 9, which is 3, plus 2 is 5. Let's plot those points. 0, 2, 1, 3, 4, 4, and 9, 5. Estimated. If I don't give you enough room, just kind of give it a little extra there. Look how it takes like half the shape of a parabola. Let's do our other one. Square root of 0 minus 3 is negative 3. Square root of 1 minus 3 is negative 2. Square root of 4 minus 3, well, square root of 4 is 2, minus 3 is negative 1. Square root of 9 minus 3, well, that's 3 minus 3, which is 0. Let's plot our points. Notice it's just 3 units down. 0, negative 3, 1, negative 2, 4, negative 1, and 9, 0. So all we've done on this page is move things. Ready? This entire area, we've just moved the equation, the parent function, up and down. On this section, we're going to practice moving it horizontally. We're going to practice moving it left and right. Notice now that the number is inside with x. Notice now that the number is inside with x. So if I break it up, let's just rewrite it so we have some more room to work with. Okay? Here we go. Let's make our XY chart. Where do you think we're going to start this one? This time we're going to start at negative 4 because it's plus 4 inside. So we're going to do negative 4, and then we always go up another number, so negative 3. Then we go up 3 numbers to 0. Then we go up 5 numbers to 5. Let's try that with this one. Where are we going to start on this equation? Well, we do opposite of what's inside the square root. So we're going to start at a positive 1. So we'll do 1, and then we go up 1 unit to 2, and then we go up 3 units to 5, and then we go up 5 units to 10. And that's always the increase. Okay, now what we have to do is plug in these numbers. So we're going to do the square root of negative 4 plus 4. Well, negative 4 plus 4 is 0, and the square root of 0 is 0. Now let's do negative 3 plus 4. Negative 3 plus 4 is 1. The square root of 1 is 1. Now let's do 0. We do 0 plus 4. Well, 0 plus 4 is 4. Square root of 4 is 2. Now let's do 5. We do the square root of 5 plus 4. Well, 5 plus 4 is 9. The square root of 9 is 3. Let's plot these points. Negative 4, 0. 1, 2, 3, 4 there. Negative 3, 1. 0, 2. And 5, 3. Notice we have not changed the shape at all. We just moved it to the left. Let's plug in these values. 1, 2, 5, and 10. So we'll do the square root of 1 minus 1, which is 0, makes 0. Then the square root of 2 minus 1 is 1, square root is 1. Then the square root of 5 minus 1 is 4, square root is 2. Then we do the square root of 10 minus 1 is 9, square root is 3. So let's plot our points. Over 1 up 0, over 2 up 1, over 5 up 2, and then you need to really count this one, 10, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that one just needs to get eyed up. I obviously didn't give you quite enough room, but just eye it up and move it over. Alright. Now these ones, all we're going to do down here is let's go ahead and just make an XY chart. We won't take the time to graph these. Let's just practice making our XY chart just so you're okay with that part for now. What would you start at for this one? Well, I hope that you would start at 3. Okay? So you should go 3, up 1 to 4, up 3 to 7, up 5 to 12. And in this one, I hope that you would start at -2. So you go -2, up 1 is -1, up 3 is 2, up 5 is 7. Now let's just make sure you're okay plugging these in. You ready? 3 minus 3 is 0, so the square root of 0 is 0. 4 minus 3 is 1, the square root of 1 is 1. 7 minus 3 is 4, the square root of 4 is 2. 12 minus 3 is 9, the square root of 9 is 3. Let's do this one. -2 plus 2 is 0, square root is 0. -1 plus 2 is 1, square root is 1. 2 plus 2 is 4, square root is 2. 7 plus 2 is 9, square root is 3. So this one would have moved it to the right, 3. This one would have moved it to the left, 2. Now let's take a look at problem 3, but we'll do that on the next video.